So in this video we are going to discuss about how to draw a schematic and how to do pre-layout simulation in electric EDA. Okay, usually electric EDA will be having some libraries here. You can simply right click on it and you can close the library, and if no libraries are found here, you have to go to file, new library, and type the library name whatever you like. Okay, inverter YT I am going to give the name. Okay, so once it is done, you can find the library here. Then we need to create a cell so that we can draw the schematic. For creating a cell, go to cell and click on new cell and select whichever you want to do. Usually we will be doing schematic and layout in our lab, so I'll be selecting schematic and then type the name of the schematic. The name of the schematic you have to remember because the same name should be given for layout also. Okay. So we got the new window for schematic. So here you can use Ctrl G to view this grid lines, okay, or dots, whatever it is. Okay, if you press one more time, it will be disappear. If you press one more time, you can see. Okay, it will be good for you to keep the components and make the connections. Okay, so now once the schematic cell is opened, go to components. Here I am going to draw inverter. I hope you already know the CMOS circuit diagram for the inverter. So what we need to do is I need to place a PMOS and I need to place NMOS. So all these things will be appearing here in the window. PMOS and NMOS can be viewed in the schematic component window. So I can do it. So if you use a fill window option, it will be showing in a full window actually. That option you can use. I am just using that option. I am minimizing it. Now I am going to change the size of the transistors, means width. So I am going to keep 20 for PMOS and I am going to give 10 for NMOS. Okay, so this is also important, so I am just keeping it. Okay, so now I'll just place all the components and make the connection later. This is for VDD, so I am selecting this for VDD. For example, power options I need to use. I need ground, so I'm keeping this ground. Okay, I hope most of the components are placed, and now I'm going to make the connections. For making the connections, I need to click on the component which you want to connect and right click on the next component edge where do you want to connect. Okay, I'm just clicking on it, it is getting highlighted, and right clicking on the PMOS. Now the connection is made. Okay, so clicking here the PMOS and then I'm right clicking on the NMOS, the connection is made. So click here and right click on the ground, so the connection is made. So every time after doing the connection, better go to tools, DRC, and check hierarchy. So that is also important. If there is any error, if there is any connections missing, here it is not like other simulation tools. If you move the components, the connections will be disturbed. So make sure you are not moving any components after making the connections. So if you are doing it, definitely do check your DRC, design rule check can be done, so that it will be identifying most of the issues. Okay, so each and every time after making connection, better to check that. Okay, now I am going to make the connection between two gate terminals, so click on it. So I want to keep some here and here. I am making the right click, so wherever I want to bend, I am just making a right click, and to where I want to connect it, I am making another right click and connecting the gate of the NMOS and PMOS. So if you want to connect directly, you can do it, that doesn't matter. Here and for appearance I am doing this. Now I need to give the inputs and outputs. So for now to give the inputs and outputs, I am just taking this and placing it here for input, and click on it and placing it for the output. Okay. So now I need to make the connection, so click on here. I need to connect this, the gate terminals, and I need to connect this with the output. Okay, so now I made all the connections. All the connections are made. Now I need to specify which one is the input, which one is the output, which one is the power or VDD, and which one is the ground. So in order to do that, I need to select the particular terminal, go to export, create export, and I am going to give it as in. In I am going to use for input. So I am going to select input. In export characteristics I am selecting inputs. That's okay. And select the output terminal, go to export, create export, and type out. So I am going to use the terminal as out. Go to export characteristics, select output, and press OK. Now I am going to select this. Okay, this is VDD. Okay, VDD terminal. Go to export, create export, and typing it as VDD, and go to output, and I am going to select as power, because that is what I'm going to give the power. Okay. Now select the ground terminal. So if you are selecting it, if you see, you can see the highlighting connections between the ground and to the terminal which you connected. Okay. So go to export, create export, type G and D, and this will be ground, and press export characteristics will be ground, and press OK. So if you press output, you can see the connections. Input, you can see the connections. Select VDD, you can see the connections. So whichever terminal you are selecting, you can see the connections made to the next terminal. Okay. So all the connections are done. Okay, actually the simulation can be done using Spice also. Now in this video I am not explaining that. In the next video I will be explaining it. So now I am going to do the simulation in this electric EDA itself. How to perform the simulation here. Here we have tools, simulation, and you can see ALS simulate current cell. Click on this. So this window will open. So in that you have to select the input which you like to change. Here IN is the input name which I am giving. Okay, you can see the output window here. The input is 0, so output is 1. So see the vertical dotted line which I am moving now. Okay, this vertical dotted line you can place wherever you want. Okay, now this part is very important. Now I am going to change the input. If you want to change the input, you have to press V. Okay, after placing that dotted line to one place, you can press V, so that it will become 1. So once it becomes 1, your output will be changed to 0 after some time. So considering there is some delay, okay, due to gates. Okay, so if you want to change the input further and move that and make sure the input is selected. If you want to make it 0, press G. For making it 0, I am pressing G. While you are making the input 0, your output becoming 1. You can notice that. Okay, you can notice that. Okay, so this is your pre-layout simulation. If you have any doubts, please post it. Thank you.